Hello friends, welcome to Learner's Planet. Friends, this is our first session for coordinate geometry. In this session, we'll be discussing the basic definitions and terminologies related to coordinate geometry. You might have studied the basics, in fact, in your junior classes. So we'll go for a quick recap of the terms. So first of all, let's understand what are the different type of quadrants. I just draw the figure before you. So this is a plane where we can see these lines, right? These two intersecting lines. Now this line, the horizontal line is called as x-axis and this vertical line is known as y-axis, right? Now this is O, that is origin, right? Now the right hand side horizontal portion is actually positive x-axis. We can say all the values of x will be positive this side, and this is negative x-axis. I represent it as x dash. Suppose it is x, then it will be x dash. Similarly, this is y-axis. On the upper side of this horizontal line, the vertical line, that is positive y-axis, and the line below this horizontal line will be negative y-axis. That means the values of y over here, they will be positive, and on this line they will be negative, right? And these 1, 2, 3 and 4, these are the 4 quadrants. We can call them quadrants, right? Now as I told you, in this this portion, values of x will be positive, and on this line, this portion, the values of y will be positive. So precisely in first quadrant, x and y, both of them will be positive, right? We show the values of x and y as a pair like this, right? Suppose 3 and 2. That means the value of x is 3 and the value of y is 2. That means suppose this is 0, this is 1, 2 and 3, and this is 1 and 2. So the point will be somewhere here. That's 3, 2. We can call this that as a coordinate of this point as 3 and 2, right? Coordinate of origin will be 0, 0. Right? So x and y, both of them will be positive in this first quadrant. In the second quadrant, since we are on this line x, the values of x will be negative. So in the second quadrant, x will be negative but y will be positive because we are considering this area, right? So x is negative but y will be positive, right? And in this, the third quadrant, here x is negative, here y is negative. That means in this quadrant, values of x and y, both of them will be negative. And in this quadrant, here x is positive but y is negative. So x will be positive, y will be negative, right? So this is what the quadrant system is, or we can say basic coordinate system. Okay. Now the next thing is distance formula. That is distance between two coordinates or 2 points. Right? So that is distance formula. Right? Now here we can see 2 points P and Q. Coordinates of P are x1 and y1, and coordinates of Q are x2 and y2. Now we have to find out the difference between P and Q, right? So what I do is we make a triangle that we join P and Q, then take 2 points on x-axis R and S, right? Now the distance between RS will be equal to distance between PT. That means this distance is equal to this distance, right? Now on a coordinate system, what exactly happens is, see, the coordinate of P is x1 and y1. That means x1 is this distance and y1 is this distance, right? That means the coordinates of R will be what? x1 and 0, right? Similarly, coordinate of S will be what? See, this complete distance from O to S is x2, right? So coordinate of S will be x2, 0, right? this complete distance is x2, this complete distance is x1. That means the distance RS will be what? This minus this. Getting my point? This minus this. That means x2 minus x1. So RS is x2 minus x1. Now RS is equal to PT. Okay, so the length of the PT or the distance between P and T will also be x2 minus x1. Similarly, we find out QT. Now this point Q, y coordinate is what? Y2. That means this length is y2 and here this length is y1 because coordinate of P is what? Its y coordinate is y1 and this length is same to this length. So coordinate of point T will be what? Y coordinate will be y1 only, right? So that means this complete distance is y2 and this distance is y1. That means QT will be this minus this, right? QS minus TS, right? So that will be QT. So QT is equal to QS minus TS. Right? So QS is Y2 and TS is Y1. Right? So X2 minus X1 is RS and PT and QT is Y2 minus Y1. So we got this length, we got this length. Now to find out the length of the PQ, since it is a right angle triangle, we can use Pythagoras theorem. Now according to Pythagoras theorem, PQ square will be X2 minus X1 whole square, that is RS square plus PT square. No problem, value of RS and PT is same. So it is PT square plus QT square and QT square is Y2 minus Y1 whole square, right? So PQ square, that is distance between P and Q, square of that is equal to X2 minus X1 whole square plus Y2 minus Y1 whole square. That means difference between X coordinate square plus difference between Y coordinate and square, right? So exact PQ will be equal to square root of X2 minus X1 whole square plus Y2 minus Y1 whole square, right? You need to take the positive value of this expression because the distance between 2 points will always be positive. So this is how we can calculate the distance between 2 points, and that is actually known as distance formula. We'll be using distance formula in solving the questions when we have to find out the distance between 2 points, right? So that's very important. You need to learn this formula. You should memorize this formula. Okay. Now the next important point over here is section formula. What section formula means is, suppose we have a point, 2 points A and B, and a line joining A and B is there, and there is a point P on this line that divides this line in the ratio m1 is to m2, right? The point P is somewhere in between A and B, not exactly in middle, not necessary, and it divides the line AB in the ratio m1 is to m2. We have to find out the coordinates of P, right? So this is what is the section formula that we are going to derive, right? Now we have the point A and point B. The coordinates of A as x1 and y1, the coordinate of B as x2, y2, and we have to find out the coordinates of P which are x, y, right? We assume them to be x and y, and we have to find out the values of x and y, right? Now PA and PB, the ratio of PA and PB is m1 is to m2. Right? Now what? See this triangle PBC and triangle PAQ, both of them are similar. I can write triangle BPC is similar to triangle PAQ, right? This line is parallel to this line, so these two are corresponding angles, they are equal. This is 90 degree, and so that's a similarity, right? So triangle PAQ is similar to triangle BPC. Now if the two triangles are similar, their sides will obviously be in the ratio. So BP by PA, I can write BP by PA is equal to PC by AQ is equal to BC by PQ. Now PA by PB, that is PB by PA, it is M1 by M2. So I put up the values over here, M1 by M2. Now PC is this length. Now from this point to this point, the complete length is x2, right? You can see the coordinates of x-axis over coordinate, x coordinate over here will be x2. So this complete length is x2, and this length from Q to S, the length will be x, because this is x coordinate over here is this small x, right? So this complete length is x2 and this complete length is x. So ST, that is equal to PC, will be OT minus OS, right? OT minus OS, that is PC. Okay, so OT is x2 and OS is x. So PC will be x2 minus x, right? Now AQ will be equal to this length, that is x, minus OR, that is x1, right? So that is x minus x1, okay, is equal to BC by PQ. Now BC is what? See, this complete length is y2. This complete length is y2, right? And from this, if we deduct this length CT, that means BT minus CT, that will be BC. So BT is y2 and CT is y, because this is y coordinate. So it's y2 minus y. By PQ, same, this complete length is y, and from this if I subtract QS, that is y1, I'll be getting PQ, right? So y minus y1. Okay, now we take these two, so that is m1x minus m1x1 is equal to m2x2 minus m2x. Now I take x, both the x at one side, so m1 plus m2 is equal to m2x2 plus m1x1, right? So value of x will be m1 x1 plus m2 x2 upon m1 plus m2. Similarly, value of y will be m1 y1 plus m2 y2 upon m1 plus m2. So we had to find out the coordinates of x and y. So coordinate of x and y can be obtained like this, right? If you know the value of both the coordinates, x values of x1 y1 x2 y2, and the point P is dividing in which ratio, maybe 2 is to 3, maybe 4 is to 5, whatever is the ratio, we can find out the value of or coordinates of P using this section formula, right? Now what happens if suppose P is the midpoint? If P is the midpoint, then what will happen? M1 will be equal to M2, right? This value will be equal to this value, right? So M1 is equal to M2. Now what? I put up the value of M1 as M2 or M2 as M1 in both the cases. So X will be M1 X1 plus, instead of M2 I'm putting M1 once again, M1 X2 upon 2 M1. So I can take M1 as common, so that will be X1 plus X2 by 2. So this is what X coordinate, and similarly Y coordinate will be Y1 plus Y2 by 2. So if we have two coordinates x1 y1 and x2 y2, coordinates of the midpoint, suppose it is xy, then it will be x1 plus x2 by 2 and y1 plus y2 by 2. So this is going to be an important formula. Both this coordinates of midpoint and section formula, both of them will be used while we will be solving the problems. So you should learn them, you should memorize them. Okay. Now the next thing, we are going to find out the coordinates of centroid for a triangle. Now we have a triangle A, B, C. Coordinates of A is x1, y1. Coordinate of B is x2, y2. Coordinate of C is x3, y3. And this is G. It is centroid of this triangle, right? Now you must be knowing that centroid divides the median. This is what AP, BQ and CR, the three are medians. Now, if the centroid divides the median in the ratio 2:1, right? Okay, so what we have to do? We have to find out the coordinates of G, that is centroid. Now, how do we do that? See, first of all, we know that P is the midpoint of B and C. And how do we find out the coordinates of midpoint? That we have already derived. This is x2 plus x3 by 2 and y2 plus y3 by 2. x2 plus x3 by 2 and y2 plus y3 by 2. These are the coordinates of midpoint. Now we have to find out the coordinates of G. We know the coordinates of P, we know the coordinates of A. Now we also know that G divides in the ratio 1:2, right? The line AP is divided by centroid in the ratio 1:2, right? So we can use the section formula to find out the coordinates of G. I assume them to be X and Y, right? So this point P is x2 plus x3 by 2 and y2 plus y3 by 2, and this point A is x1 and y1. We have to find out the coordinate of G that divides this line in the ratio 1:2, right? Now we can directly use section formula. What was the section formula? If the coordinate of this point is x1, y1 and this is x2, y2, and this may be any point that distributes in the ratio m1:m2, so that is m1 x2 plus m2 x1 by m1 plus m2, right? Here m1 and m2 are 1 and 2, and x1 y1 this is this and x2 y2 is this. Okay, so we directly use the section formula over here. So this into this into this, right? So x2 plus x3 by 2 into 2 plus x1 into 1 by m1 plus m2, that is 1 plus 2, that is 3. So this is what? X1 plus x2 plus x3 by 3. Similarly, y coordinate will be y1 plus y2 plus y3 by 3. So these are the coordinates of centroid, right? x1 plus x2 plus x3 by 3 and y1 plus y2 plus y3 by 3. So these are the coordinates of centroid. Direct question can also be asked, find out the coordinates of centroid for a given triangle. Then you can use this particular method, right? And while you are calculating, while you are taking the line CR, you take the midpoint of ABSR, then the coordinates of R will be x2 plus x1 by 2 and y2 plus y1 by 2. In the similar manner, if you calculate, if you find the coordinates of centroid, you'll be getting the same expression once again. That means in all, we can say that all the medians are passing through a common point. That means the medians are concurrent, right? They are passing through a common point, and that common point is actually nothing but centroid. And what are the coordinates of centroid? That we have calculated. Okay. Now friends, let's find out the area of the triangle when the coordinates of the three vertices are given. We have the triangle ABC. The coordinates of A x1 y1, coordinates of B x2 y2, and coordinates of C x2 x3 y3. Right? Now we have to find out the area of triangle ABC. Right? First of all, what we do, we drop a perpendicular from A, B and C on x-axis, right? So we have the 3 points Q, P and R. Now we have to find out the area of triangle ABC. How can we do that? You can see this trapezium ABQP, right? Area of trapezium ABQP plus area of trapezium APRC, right? Now from ABQP and APRC, this is this complete figure, right? Now from this, if we deduct the area of trapezium BQRC, we will be able to get the area of triangle ABC, right? This area plus this area minus this area will give us the area of triangle ABC. Now what is the area of trapezium? What is the formula for that? That is half sum of parallel sides into distance between them. Right? Now first of all we find out that area of triangle, trapezium ABPQ. AP, Q and P, right? Coordinates of Q will be what? This coordinate is x2, so coordinates of Q will be x2 0, coordinate of P will be x1 0, coordinate of R will be x3 0, right? So length of this is y2 and length of this is y1, right? So sum of parallel sides is what? y1 plus y2. Distance between them, that is QP. From this point to this point it is x1 and from this point to this point it is x2. So this is x1 and this is x2. So this length will be OP minus OQ, that is x1 minus x2, right, by 2. So this is x1 minus x2 into y1 plus y2 by 2, that is area of trapezium QPAB. Okay, similarly we can calculate the area of trapezium PRCA. So that is once again sum of parallel sides. So sum of parallel sides is what? This is y3 and this is y1. So y1 plus y3, distance between them, that is OR minus OP. Now OR is what? X3 and OP is what? X. So x3 minus x1, sorry, this is what? X1 by 2. So this is area of trapezium APRC. This plus this minus area of trapezium BQRC. Now what will be the area of trapezium BQRC? Sum of parallel sides, that means BQ plus RC. Now BQ is what? Y2 and RC is what? Y3. So that is y2 plus y3. Now distance between them is, this complete distance is x3 and this complete distance is x2. So that is x3 minus x2 by 2. Now this is what the area of the triangle. Now let's simplify this. I take 1 by 2 as common. Then this is x1 y1 plus x1 y2 minus x2 y1 minus x2 y2. Then this is x3 y1 plus x3 y3 minus x1 y1 minus x1 y3. Then this is minus x3 y2. Then this is x3 y3. Then minus x2 y2 and this is plus x2 y2. Then minus x2 y3 and then this is plus x2 y3. Right? So let's simplify this. x1 y1 and x1 y1 cancelled, then x2 y2 and x2 y2 cancelled, then we have x3 y3 and x3 y3, they are cancelled. So finally we are left with half x1 y2, this is x1 y2 and this is x1 y3. So I can take x1 as common, y2 minus y3. Similarly here we have x2 y3 and x2 y1. I take x2 as common, so this is y3 minus y1. Similarly I have x3, so that is y1 minus y2. So this is what the area of the triangle. Friends, we can directly use this formula to find out the area of the triangle when the three vertices are given, right? And this derivation is really important, so just try to write it 2 to 3 times, you can memorize it. Okay. So friends, in the next session we'll be discussing the problems on coordinate geometry. Just revise this session, be clear with all the formula, distance formula, section formula, how to find out the area of the triangle, how to find out the coordinates of centroid and all that. So you'll be comfortable while we will be solving the problems in the next session. Okay, so bye bye.